Right, here's example 1. What mass of iron 3 oxide is required to produce 100.0 grams of solid iron? This question is not complete. It is missing some information that you would need to write the proper equation. I will provide that. So we always need to start with a balanced chemical equation. So there's our correct formula for iron 3 oxide. It's going to be a solid. It's an ionic compound. This is going to react with carbon monoxide gas. Again, that wasn't stated in the question. It should have been. This will produce iron. Iron's a solid at room temperature. And carbon dioxide gas. Again, you weren't told that. You should have been. So here's the skeleton equation. But this needs to be balanced. So I'm going to balance this up 2. I'm going to put a 2 there. Oxygens now, there's 2. There's 4. I'm going to need a 3 there and a 3 there. 3 carbons, 3 carbons. 2 irons, 2 irons. 3 plus 3 oxygen is 6 oxygen. 3 times 2 is 6. All right, there's the balanced chemical equation. Now I'm going to identify what I know and what I'm asked to find. So the question says, what mass of iron 3 oxide is required? So that is what I want to figure out. Well, what information do I have? I have that 100.0 grams of solid iron is produced. That's all I have. What we need to do is convert this amount into moles. Use the molar ratio to find moles of this reactant, and then convert that to mass in the final step. Well, you can always figure out your molar masses. If you look on the periodic table, the molar mass of iron is 55.85 grams for every 1 mole. Well, we can also figure out the molar mass of the iron 3 oxide. We have 2 irons, 3 oxygens. If you were to add that all up, you would get 159.70 grams for every 1 mole. All right, so step 1 is going to be figuring out the moles of the iron. So moles of Fe, we're going to take our mass and we're going to divide it by the molar mass. I like to write this out like this. So I'm taking the mass and I will be dividing it by 55.85. But writing out like this, basically how you would divide a fraction is you end up multiplying and switching the numerator and denominator. I can see that grams are going to cancel out, and I'm going to be left with the unit that I want, which is moles. 1.791 moles. U2, 100.0 times 1 divided by 55.85, or just 100.0 divided by 55.85. So let's ask ourselves, does this make sense? We have almost 2 moles. Well, we have 100 grams. 1 mole is 55. We have more than 55. Do we have twice as much as 55? No. So this is a very reasonable amount of moles. We can be confident that we have calculated this correctly. Step 2. Now that we know how many moles of iron we have, we want to find out how many moles of the iron 3 oxide. It is a 2-to-1 ratio. And I just want to point out that at this point in time, you don't need to worry about the carbon monoxide and you don't have to worry about the carbon dioxide. They were needed to get the right stoichiometry, the right molar ratio of 1, 3, 2, 3. But from here on out, we're only worried about this and this. For every 1 of these that reacts, we get 2 of these. So step 2, find moles of Fe2O3. And we're going to use our molar ratio. I'm going to write the molar ratio just over here to the side. So we have 2 moles of Fe for every 1 mole of Fe2O3. Fe2O3. It doesn't matter which you write on the numerator and denominator. They can be flipped as necessary. So we want to find moles of Fe2O3. We're starting with 1.791 moles of iron. Add in this detail here so that you apply this mole ratio correctly. Because just as you saw in the video on mole ratio, we need to decide how we're going to use this. Is the 2 moles of Fe going in the numerator or the denominator? Well, we want this to cancel out, so it needs to go in the denominator. The moles of Fe2O3 is what we want to find. It needs to go in the numerator. Moles of Fe cancels out with moles of Fe, so we want 1.791 times 1 divided by 2. That is going to give us 0.8955 moles of Fe2O3. Now ask yourself if that makes sense. It's a 2-to-1 ratio. Every 2 of these that are produced, we needed 1 of these. We had 1.791 moles of Fe produced. We need half that amount of the iron 3 oxide. Is 0.8955 half of 1.791? Yes, it is. Step 3, we need to find the mass of the Fe2O3. And now that we know the moles, that's easy to do. You're practicing that last week. So find mass of Fe2O3. Little m. So we have 0.8955 moles, and we are going to multiply that by our molar mass of 159.70 grams per every 1 mole. Moles cancels out, and our mass is 143.0 grams. Let's go back to our original question. Here is a measurement. We have 4 sig figs in this measurement, so our final answer needs 4 sig figs. So therefore, the mass of Fe2O3 required is 143.0